Alright, so today we'll be talking about kinematics, or the study of motion. Some important variables to keep in mind are v for velocity, d for displacement. We can also use x for this variable, a for acceleration, and t for time. We'll be mainly focusing on velocity and displacement today. Velocity and displacement are both vector quantities as opposed to scalar quantities. Scalar quantities only have magnitude, which is also known as size. On the other hand, vector quantities have both magnitude and direction. Some examples of scalar quantities will include distance, speed, and time. Vector quantities will include the above-mentioned displacement and velocity, as well as acceleration. Oh, I spelled that completely wrong. Okay. The key difference between the two is that scalar quantities do not have direction. For example, you cannot say that there is negative time, or you traveled a negative distance at a negative speed. But you could say that there is a negative acceleration on that person, or that person is experiencing a negative velocity or a negative displacement. Keeping that in mind, let's move on to displacement. Displacement is how far an object moves from one position to another. This is also known as just a change in position. Keep in mind that displacement should not be confused with distance. Even though they could sometimes share the same value, they do not have to always share the same value. Distance is just how far an object moves. Not the change in position that displacement is. A good example of this is running on a track. For example, let's say that 4 laps on a track is equal to 1 mile. 1 mile would be the distance covered. As that is how much you have traveled, or how far you have traveled. However, assuming that the starting position and the finishing position of the track is the same, even if we run 4 laps, the displacement would be 0, because you're not changing in position, as the start and the end snapshots are the same. This is because to find displacement, we need to analyze moments in time and look for the motions between them. In this case, we will look at the start position as well as the end position, and as they are the same spot, there's no motion between them, so there would be no displacement. Moving on to velocity. Velocity is just the change in displacement over time. Oh wow. This is pretty self-explanatory because you get the quantity of velocity when you time a displacement. With those two definitions in mind, we will now see the equations for them. For displacement, the equation would be change in x is equal to x minus x naught. The little diamond is delta, the Greek symbol for change in, while naught is origin or original. To find displacement, we would subtract the second snapshot, or second position, by the first. This equation can also be written as x2 minus x1 or x final minus x initial. It really depends on which subscripts you like better. Moving on to velocity, which is just change in displacement over change in time as per the definition, is just v equals delta x over delta t. This can also be written out as x2 minus x1 over t2, oh, not x, that would be t, minus t1, if we were to write out the change in. So, to find velocity, we would take the displacement and divide by the change in time. Oh, spelling errors everywhere today. On the topic of change in time, the change in time equation would just be change in time is equal to t minus t naught. You would take the second value and subtract it by the first. Another thing about velocity, sorry, forgot about that, is that the average velocity isn't always consistent. that's just something to keep in mind. Now, the units for displacement generally is meters. Units for velocity, meters per second. And then for time, it's just seconds. This makes sense because velocity is change in displacement over change in time, which would make meters per second make sense in terms of units. Going back as a review, we reviewed over some variables that are used in kinematics, and then established that displacement and velocity are vector quantities. We figured out that displacement is how far an object moves from one position to another, or just simplified as change in position, not to be confused with the scalar value of distance, which is just how far an object moves. Velocity is the change in displacement over time, or where you time a displacement. Then we went over the equations of displacement, velocity, and time.